webinar, SAF webinar, organized under the EU Southeast Asia CCCA CORSIA project. Today we are going to talk about sustainable aviation fuel, feedstocks and regulations once again, but going a step further also in detail. More about it in a moment, because I want to give you a brief update of brief introduction, where we are coming from, what we are doing, and how this webinar has to be put into context. So as said, European Union Southeast Asia CCCA CORSIA project funded by the European Union, a project aiming to support the ASEAN member states in the reduction of CO2 emissions from international aviation. We are focusing on CORSIA implementation, support state action plan for CO2 reduction, emission data management systems implementation, and we're giving advisory on climate change policies. My name is Ralf Kosman. I'm the operational manager of this project. Some practicalities and about the colleagues again joining us: Santiago Hayaleva, our project manager; Rebecca, supporting us in administration and communications. Question and answers, please always raise. We have a Slido application at the bottom right corner of your screen. You can access it either through the QR code or by entering in capital letters Sierra Alpha Foxtrot 13 SAF 13, and then you will open the Slido application, and we want to encourage you to raise questions at any time. Please don't hesitate. Now my computer is not responding. I'm not going to the next slide, but I think it happened now. Okay, there was something in between. So again, back to the subject: SAF, feedstocks, and regulations. Let me introduce you directly, and again, I'm struggling with my presentation. Now it's there. And let me straight introduce you to our main speaker today. It is Georg, full name entitled Dr. Georg Markowz from CBR Consultancy, and we have joined our colleagues from the company already 2 weeks ago. It was with Christoph and Chiara on board. I'm not going to dive into his impressive professional background, but just to focus on his core focus at CBR. He's doing technology assessments and economical analysis and technologies related to renewable liquids and gases, etc., giving you an insight of how we prepared this webinar. We have been looking into Georg's presentation, and we have experienced that it was, from our impression, maybe the most complex we have had so far, and up to a point that we were asking ourselves whether this is the right content given the limited time, the format, and we deliberately said, yes, let's give it a try. For us, it is a bit of a test case, a pilot, and this is why we want to encourage you even more to raise questions at any time. We can also interrupt, and we're probably also going to interrupt Georg here and there, trying to make it really an iterative experience for all of us. And we're going to share a survey right after the end of this webinar, and please let us know your feedback. Let us know whether you liked it, where the problems were. To be honest, I also needed time, and my colleagues needed time to digest everything, but the more we thought about what Georg was telling us, the more we liked it, and we didn't want to miss sharing this with us. And the nature of what Georg is doing is really to look also critical into what we are doing, in order to see that we are going all into the right direction, that the regulations are fitting the purpose, that there are no pitfalls, because nothing is static. The business is not static, neither are regulations, and they need to be adapted as well. So I'm very much looking forward to it, and I want to encourage again all of you to, because I experienced it myself and Santi as well, the more focus we're going to try, I think the more benefit we're going to take from the event today. So Georg, thank you very much for being with us. I'm really looking very much forward to the next 50 to 60 minutes we're going to have together. Quickly also about Christoph. For the ones who are joining us on a regular basis, you have met Christoph, as said, 3 weeks ago. He's a founder of the company, and so also Christoph, thanks a lot for being with us as well. You're not going to present today, but you're going to be with us also in the question and answer part. So we're trying to make it as interactive and collaborative as possible. I've said enough for today. Georg, the floor is yours. Please, if you can, try to just push the presentations through and get us started.
Yeah, thank you very much, Ralph, for your kind introduction, and thank you also together with Santi and Rebecca for setting up this workshop and inviting us, giving us the opportunity to share some views, some expectations, some thoughts on a really complex subject. Throughout the presentation or the workshop, there will be 5, let's say, guiding questions which we will address in one or another way. So the first question is about how the feedstock topic is linked to the overall development of SAF. And as you will see, there are quite different views on how the SAF world will evolve. Then the question will come up how the selection or the competitiveness of various technologies might impact the dominance of one or other feedstocks. Then next, we will have to think about potential competition from other sectors. We're not alone in the SAF world. There are other parties strongly putting their bets on renewable carbonaceous feedstock, not only for production of SAF. Then I would like to point out something that is, from my point of view, rather underrated so far, and that is the differentiation between renewable energy, what we typically talk about, but also renewable carbon as a separate topic, since they are not always impacted by regulation and technologies the same way. Well, and then, as you will see through the course of the presentation, there are trends to be kept in view and to be considered, and we will collect them and summarize them at the end. To start with, you see here a slide which some of you may remember from the second last workshop presented by my colleagues Chiara and Christoph. It is a very nice slide to put us in the right context of today's topic. It shows a diagram which I'm pretty much sure most of you have already seen in one or another or similar ways. It shows the global CO2 emissions from aviation, and before COVID we were somewhere above 1 billion tons per year, and then we had the COVID drop, and then there's the expectation that based on a kind of business as usual scenario that would increase, and ultimately I've seen numbers without any additional action, aviation could contribute to about 20 to 25% of the global greenhouse gas emissions by 2050 if we don't do anything to reduce the emissions. Now, this has been early on addressed, identified, and there are several, let's say, categories how the reduction of the greenhouse gas emissions shall occur. And there's quite broad consensus on which kind of tools or means will be applied. Like, we will have efficiency gains, we will see additional efficiency gains due to increased level of ambition. We will see new fuels like hydrogen, or even in the short range battery electric airplanes. So all this contributes to reduction compared to the business as usual case. And then you see here in orange and light green and darker green already indicated some significant share of sustainable aviation fuel. If you take that example here and take the sum of those, let's say, SAFs here, this is about 40% here, and compare that level to where we are today, then you get an idea of what that roughly could mean in terms of fuel demand. And as we were pre-COVID around 360 million tons, it is not surprising that some studies forecast that we will need by 2050 something around 300 to 500 million tons per year. Now, interestingly, when you dig deeper into various into various studies, then you find out that there is a significant spread of forecasts. First, within single studies, like the long-term aspirational goal study of IKO. So what you see here is the reflection of various boundary conditions that could have an impact on the course of the ramp-up of SAF demand. But you also see a broad range of forecasts between several studies. And interestingly, there are also studies which are very conservative regarding, or forecasts that are very conservative regarding the fuel demand by the global fuel demand by 2050. And already to indicate the connection to our today's topic, for example, the S&P Global Insight, Commodity Insight study, they, among others, state, well, there will be high competition from other sectors, such as the diesel market, providing a higher willingness to pay, and therefore a lot of the fuel and thus the feedstock goes in that direction. And the article further states, yeah, there might be feedstock limitations. So that overall, if you compare this number here with, let's say, the average or even the highest level of forecast, there's let's say a difference of more than order of a magnitude. So let's say the course of SAF ramp up and development is highly dependent on many parameters, and to be very frank at this point, it is apparently very uncertain to find a clear view on how this SAF market and the ramp up may evolve. In other words, there is no common understanding as of today, and thus also no clear planning basis on how much feedstock do we actually need, and do we have enough feedstock, and do we have taken all the means and measures to provide all that feedstock? Now, one could question, do we have to take such studies serious? I mean, don't we have enough feedstock? And in this context, it's helpful to take a look, let's say, into science and public literature. And what you see here is a very interesting result or diagram from a meta-study where various sources in the literature about forecasted bioenergy potentials for 2015 have been assembled, compiled, and then sorted and assessed. And the diagram is to be read in the following way. You see the biomass energy potential, the global, and I'm pretty much sure no one feels really comfortable with exajoules. So I put an orientation. So 100 exajoules would mean roughly 2,400 million tons of oil equivalent per year. So this is really significant, but we also have to consider this is a global number. Now, the study collected data already specifically in view of what sort of biomass could really be accepted by 2050, also from a regulatory point of view, and has made up those 4 categories. And now each of the category or each of the bars is to be read in the following way. The values at the lower level in blue indicate the the highest level of agreement on whether such a value can be achieved. For example, for dedicated crops, 100% of the studies would agree that 25 exajoule can be made available. So no worries, no debate or controversy about this. But the higher you move, the less studies or the less experts, the less people agree that so much energy can be made available. So you could interpret such a diagram first in the way that you say, well, there are significant quantities available, especially if you look at the red indicated values. However, you could also pursue a very conservative view and say, well, if I take only the blue ones, then the quantity stays relatively low. And although this number seems to be high here, 2,400 million tons oil equivalent, we always have to keep in mind that there are other parties in the world, in the value chains, in the industry, who also have a strong interest in that. So we have first, again, a high uncertainty, or you could say disagreement or a lack of consensus of what is really available, and therefore a lack of planning basis. And secondly, we have no planning basis to make sure how does that relate to our projections regarding the SAF demand. And so if you take really a very conservative look, then you can better understand why some of the studies mentioned earlier conclude we really could end up with a feedstock limited world where SAF uptake is not primarily determined by the will of the parties, but by the lack of feedstock. You could translate it into ultimately the cost of feedstock. Now, this is not only let's say the perspective from science, but also policies can have an impact on.
Georg, if I may, sorry for bother. If I may take the privilege to bother you with the first question or just reflection, do you say that according to what you say here in this slide and the previous one, we are safe on feedstocks? So the potential is there, and there we don't need to worry. Is that the essence?
Thank you for giving me the opportunity to clarify that. Yes, you could read the diagram in this way, that you say, well, we have 2,400 million tons of oil equivalent per year, and if I add only the most conservative numbers here, like about 10 exajoule here, something like 42 times 25, I end up at 100 exajoules, which is 2,400 megatons. Now, if you take the average of the forecast from the previous slides, say 400 million tons, so you could say, well, we have a potential, even in the most conservative scenario, of 6 times the demand for SAF. That sounds very promising. On the other hand, please keep in mind, we have marine fuel demand, we will have demand by the chemical industry, we will have a huge demand for heating, process heat, especially high temperature heat. We might have demand for other heating purposes, so not everything can be electrified. So be very careful whenever you, and this is something I couldn't repeat often enough, whenever you talk about feedstock potential and demand potential, always think at the same time how much demand could arise from other sectors. So in this regard, the number of 2,400 million tons, so the sum of all the conservative potentials, might be too low to serve the whole market. Okay?
Thank you.
Yeah. Now, we have to keep in mind that independent on how science classifies and investigates feedstock potentials, there's also regulation to be observed. And this shall be illustrated on the comparison of two prominent, let's say, regulatory frameworks, which are often discussed today in the context of SAF. The one is CORSIA, for sure, and the other is the Renewable Fuel Aviation Directive in combination with the underlying Renewable Energy Directive, because the latter provides several details which apply also then to the refuel aviation. And alone, if you look at the list of eligible feedstocks, and last week Daniel Bruce Rivas has given a really a nice and detailed presentation on that subject, then you see that yes, there are waste and byproduct and feedstock, but a significant portion is made up by what is called main products, so food and feed crops or primary biomass. Besides, there is a significantly lower entrance barrier into the SAF world. So the minimum greenhouse gas saving demanded for such fuels is much lower than the minimum greenhouse gas saving according to the refuel aviation. And besides, refuel aviation explicitly excludes from the beginning on all kinds of feed and food crop based feedstock. Now you could say, well, this is only one of 5 categories here, but if you look at scalability, at mass potential, then it is very clear that by mass, this is a really significant quantity of feedstock that is not eligible for application under the refuel EU. In other words, the feedstock potential, the overall feedstock potential, according to refuel aviation, is much smaller than based on the CORSIA. Now, if we compare such regulatory frameworks, one could say, well, why don't I stick with the regulation which provides a broader range of feedstock and which provides more options so that the pressure on feedstock markets is not as high. Yes, this is one view at the topic. However, to have the full picture, we have to keep in mind that opening up the feedstock potential or the pool to such sort of feedstock goes in tendency along with somewhat lower greenhouse gas savings. And that is also addressed. What you see here is a diagram. Please don't necessarily look at all the detail fuel types and paths. What you see here is a list of different fuels being eligible under CORSIA and their respective greenhouse gas savings. So the higher or the broader the bar, the respective bar, the higher the greenhouse gas savings. So here you would have 100% greenhouse gas saving. Now, as you can see, there is a broad, let's say, differentiation between the various paths. That is not really surprising. I also added the minimum greenhouse gas saving according to refuel aviation and highlighted the cases where the respective greenhouse gas saving of the eligible fuel does not meet the minimum greenhouse gas saving according to refuel aviation. And if you then look at what sort of feedstock are we talking about, then you find out that very often it is the fuels that are produced from feed or food crops. So you have a kind of conflict. On the one hand, you have a higher feedstock potential. On the other hand, that goes in tendency along with a lower greenhouse gas saving. And lower greenhouse gas saving in turn means ultimately, so say by 2050, you have to close the gap to 100% to really be able to reach 100% greenhouse gas saving as needed for globally. So what it means is if you rely or if you put your strategy on application of such sort of, for example, on corn-based fuels, then you always have to think about a strategy. How do I ultimately want to close the gap to 100% greenhouse gas saving? Now, in view of that comparison, one could say, well, isn't the EU making it almost impossible to ultimately fulfill at the same time highest sustainability criteria and to have enough biomass? And in this context, I would like to point out that the EU is continuously screening and assessing and clarifying which sort of eligible feedstock might be added to the list of clearly eligible feedstock. And for example, by the end of the last year, a new, let's say, extension of the respective list has been published for public consultation. So for waste and residue-based fuels, there are, if those will be finally recognized, there will be a broader list of feedstock available also for soft production. So this is the good news. There is, however, if one takes a closer look, and you really need to dig in a bit into the documents, you find out that many of them are really, say, niche type feedstocks. So, for example, you can take methanol as a side product from black liquor in the pulp industry. Yes, this is a really attractive potential and commercially perhaps a relatively low-hanging fruit. However, the absolute mass or volume potential isn't really very big. So let's say the number of topics here shouldn't lead to the wrong impression. Well, we have a great mass potential, so it really needs understanding. So what does every single topic mean? Except, in fact, for two aspects where I personally am quite, let's say, optimistic and where I think we are on a very good path. And that is, on the one hand, the so-called cover crops. So cover crops between the plantation and harvest of the main crops. So to benefit from that phase during the course of the year. And the second is the use of feedstock deliberately grown and harvested on marginal land, so land that it has been either abandoned for agriculture or has not been considered suitable for agriculture so far.
Georg, it's me again. Sorry for interrupting. Has the potential for such kind of feedstock be assessed? Do we know the magnitude? What could potentially be available from them?
Yeah, there are, let's say, for each of the feedstock, you can certainly find some literature, especially for the marginal land. I think there is really a huge potential. In 2021, there has been published, among others, a study by Kalliope Pandouzou and Kyriakos Maniatis. And they have, among others, especially looked at marginal land, and they identified, especially now, again, it's about the EU, but I'm quite sure that the findings generally can be transferred to other regions in the world. They found that, especially in southern Europe, there are increasing areas which are abandoned with respect to agriculture because they are not competitive anymore. However, if you now use them for dedicated crop agriculture or a non-crop based feedstock, that would be even better, to then provide the feedstock for fuel production, it could be very attractive not only to increase the feedstock potential, but also to avoid let's say, disadvantages of abandoning land like erosion, for example, or loss of carbon stock in the soil. So, and this study came up with numbers. They investigated various scenarios, and they said something like 5 to 10 million hectares in Europe alone could be converted to, let's say, agriculture for dedicated fuel feedstock generation, and the resulting potential was on the order of 10 to 50 million tons of oil equivalent alone from that land. Now, if you consider the pre-COVID consumption of kerosene in Europe was in the range of 40 to 50 million tons per year. So 10 to 50 million tons alone from feedstock from marginal land could really make up a significant contribution to that demand. Now, nevertheless, it is still uncertain given all these, let's say, potential challenges in how will the world evolve and how who will demand for which feedstock and where will competition be. So the ultimate question is now, will we be able to cover our demand, and especially in Europe with these high requests for sustainability? And in this regard, I would like to conclude that section with a positive outlook. On the left, you see from a study by several important stakeholder associations from the aviation industry in Europe, a prognosis where we could end up, where they, as of today, expect to end up by 2050. So that would be something like 30 million tons of oil equivalent, of sustainable aviation fuel. Now, this is to be seen in comparison to an impact assessment which the European Commission has executed in 2021 in view of the Renewable Energy Directive to see, well, how many feedstock potential do we have by 2050? And you see here for various scenarios by 2050 in the olive bars, that's the quantity according to this impact assessment from biomass waste. So the sort of feedstock which is eligible for SAF production. Now, if you take this as a rough number, something like 50 plus million tons per year, and compare that to the demand for SAF in the EU of about 30 million tons per year, that seems quite promising. So one could say, yes, so there's no reason, at least to fundamentally doubt that the expectation and the ambitions match to the feedstock supply. However, I personally, again, would like to point out that the study assumes that there is very, very little, if none, demand for diesel from the road sector. So the ambition or the underlying assumption is highest degree of replacement of diesel driven mobility, including especially heavy duty vehicles. And now everyone may ask him or herself, do I believe in that scenario? And I mean, considering that the diesel fuel sector is so much bigger than the market for, by quantity, than the market for kerosene, any change or any deviation from the assumptions made here could have a strong impact on how much of the feedstock or the biomass is ultimately really available for aviation.
Georg, can you take a look into the crystal ball and try to estimate the magnitude of the diesel demand? What do you think by 2050? What would be realistic?
Okay, let me try to...
Sorry for continuing to interrupt you here all the time.
No, that's fine. That's fine. I try to circumvent a little bit the question. I give you a calculation example. The current demand for diesel in road transport in Europe is in the range of 200 million tons per year. Now, even if you reduce that demand by 90%, you would end up at 90%. I think this is already ambitious, and this is already, it would be a great success if we can achieve that. Now, if you reduce it by 90%, then you still would have a demand of 20 million tons of diesel type fuels. Now, if you relate that to the total potential of about 50 million tons, and the soft demand, and please keep in mind there's also marine asking for fuels, then 20 million residual demand for road transport could be really significant. So in this regard, I at least suggest and recommend to keep policy design and regulation and market strategies also always open for a scenario where we have residual demand from the road sector. So it is maybe good to have that case like here, but always question yourself, is my policy adequate or prepared? What do I do if there is some residual demand? What does it mean for the other sectors? How will they then be able to comply with all the requirements?
I think that's pretty much linked to what you said at the very beginning when you said regulations have to be monitored, screened, see what is the evolution, what is the impact of hydrogen eventually on road transport, etc., just to be able to respond in time, right? That's
exactly.
Yeah. So thanks.
I fully agree. Now, despite those, let's say, perhaps concerns or considerations, I want to repeat that the core message of this slide is a positive one. So it is, we're not fully out of scope already as of today. So we will find feedstock for a significant share of SAF in the future. Now, this is the very high level, and the next question then is, well, which sort of feedstock will we see in the SAF world? And that question is very strongly related to the question of what kind of technologies to produce SAF will we see in the future. And as certainly many of you know, we have already a remarkable set of developed and certified SAF types and respective pathways to produce SAF. And all of them have their, let's say, segment with respect to potential feedstock. So now if we ask ourselves which feedstock will dominate, then this is strongly linked to the question, well, which technology do we expect perhaps to be very competitive and then thus develop a high demand for the respective feedstock segment. I would like to address that on the next slide, but before I do, and sorry for coming back to that point again and again, please also here keep in mind that, that all of those pathways are very close to producing also diesel. So all of those plants, and even if they are already installed, the barrier to switch to diesel production instead of SAF production is very low. So if there is a higher willingness in diesel markets, there might be a very prompt reaction in the market to switch the fuel mix towards diesel production and correspondingly less SAF production. Now the question, how competitive are the technologies as of today? There are also in this regard several studies which you certainly already have seen of the type shown here. So a comparison of various technologies or pathways and the course of production costs over the time. The production costs shown here are listed in euros per liter and very roughly transferred in dollar per ton. So whatever you feel more comfortable, take the numbers that apply. And what are the typical trends that you observe? And yeah, one study may have a little bit, let's say, expectation that prices are higher in the beginning or are more optimistic. But the overall trend is that for all technologies, prices are expected to come down. And when I say to come down, please always compare that to the fossil fuel price, and we all know the value of the day before yesterday shown here is just a moment or momentary value. So we have seen higher prices, we've seen lower prices, but still all of them are higher, the costs. They get lower. Some of the values might get very close to the fossil price, especially once the fossil price, for whatever reason, increases in the coming decades. And there is some, let's say, general ranking between those studies. Now, one could say, well, HEFA is the way to go. That's the cheapest, and this is most attractive. Then perhaps gasification-based or alcohol-to-jet based, and then ultimately the eSAF or PTL-SAF, or how, as the European regulation says, the renewable fuels of non-biological origin, the RFNBO type fuels. However, I would like to take the opportunity to, let's say, sensitize you that such diagrams have to be taken very much with caution, especially be careful to derive conclusions regarding the value or the interest in specific feedstock. To give you one example, we see here the HEFA range, which is very close because the technology is mature, so there's not much learning potential in that technology. And according to that study, and again, you would find similar values in other studies, we're talking about something like $1,000 to $1,500 per ton. In 2022 alone, the range of real SAF prices via the HEFA pathway was in the range of $2,000 to $3,500 per ton. So keep in mind that study had been published in, I think, 2021, and only 1 year later, prices were like 2 to 3 or up to 3.5 times higher than what was forecasted. So I don't want to criticize the studies. I only want to show that such studies can only make calculations based on specific assumptions, and that the real market may behave completely different. And especially, I would like to raise the awareness that the reason for such high prices was not the least due to high feedstock prices. So it wasn't that the technology somehow became costlier. It was basically the feedstock prices that have risen to a much higher level. So please, independent on any discussion about regulation and feedstock potential, be always very cautious in interpreting or drawing too many detailed conclusions for such sort of diagrams. Especially keep in mind that, and that is highlighted here in the last sentence, that feedstock owners will be increasingly aware of the value potential for the SAF that is produced from their feedstock. So the more feedstock owners understand the high willingness to pay, for example, driven by regulation or self-commitments or whatsoever, the higher the price of the product from the customer of the feedstock owner. So you jump to the next position in the value chain. The higher the value of the SAF, the more the original feedstock owner will ask for a bigger share of the cake of the value creation. And that is something that is not specific in the renewable fuels world that we see in the SAF market. We have seen that, for example, also in the biogas market in Europe, where suddenly, also driven by regulation, the demand for high greenhouse gas saving fuels, including biomethane for methane-driven cars, increased, and then suddenly the prices for the feedstock rise, not because the cost for feedstock generation were higher, but because the feedstock owners realized the market mechanisms. Now, if you take all those, let's say, interdependencies and complexities, I'm sorry to say it is not possible as of today to really make prognosis which technology will dominate in which way, or what it would mean for the respective feedstock segments of the technologies. However, there is one aspect which I would like to, let's say, to highlight, which is from my point of view, strongly underrated so far. And that also relates to regulation. When we look at SAF, or renewable transport fuel regulation in general, but including SAF related regulation, we see a general, let's say, option to classify according to whether rather a fuel quantity, an energy, a mass quantity is mandated, or the related greenhouse gas saving, such as, for example, under CORSIA or under the Science-Based Target Initiative. Now, when you are incentivized to produce SAF under a fuel quantity mandated scheme, then you produce your fuel, and especially when you produce it from biomass or waste, you typically have at some point in the process excess CO2. So the ratio of hydrogen and carbon in the biomass doesn't really fit to the ratio in the SAF. So you need to remove somewhere some carbon, and you typically do this in the form of CO2. Now, we are talking as of today with CO2 avoidance costs, or costs associated by the fuel production for the greenhouse gas, on the order of $500 to $1,000 per ton. In a greenhouse gas saving determined or incentivized world, you first could do the same as above, and you would have the same production cost. But now you have an option which is different, or makes sense in this case, because you can take the CO2 and instead of venting, releasing it to the air, you could take it, for example, and sequester it. Now, by sequestering, in fact, you have a carbon negative effect. You take some CO2 out of the air, and as only a portion of the CO2 bound enters into the SAF, another portion gets buried in the ground, and this CO2 is effectively net removed from the atmosphere. And the interesting point here is that, let's say, additional removal or reduction of greenhouse gas is associated with much lower costs. And please take this as a very rough indicative figure. It could be lower, could be higher. So the market is not yet really developed. However, the more you add this sort of greenhouse gas saving, the less your total costs of greenhouse gas saving. The total means I calculate basically the average of those greenhouse gas saving costs and those greenhouse gas saving costs. So there is a very strong potential to reduce my greenhouse gas saving costs, and hence to improve my cost competitiveness in the market. So what I want to say is I anticipate that more and more players will pursue that path as soon as the market for CO2 sequestration, or let's say the potential, if more projects are realized and more capacities are available for CO2 question. So overall, that option means that all the fuel paths which rely on biomass or waste, in contrast to eSAF or RFNBO SAF, where CO2 is needed. So in PTL, you don't have an excess because you need desperately any amount of CO2. So all biofuel-based technologies can have a competitive edge. And in fact, this competitive edge is even reinforced because if we take a closer look at the eSAF world, this is the let's say the demand for prescribed and provided by the very recent alignment between the European Council and the Parliament just Tuesday this week on the targets for SAF overall. and the sub-target for ESAF. Now, the sub-target for 2050 shall be 35%. That relates to, and take this as an indicative number, 14 million tons per year. And this in turn results in a demand for CO2 to produce this quantity of SAF, which is really, really remarkable. And now, please consider when all the providers of CO2, which have an incentive to bury, to sequester their CO2, are not available, then most or many of those plants will depend on direct air capture, so taking CO2 out from the diluted concentration in the air. In other words, sequestration of CO2 from bio-based SAF producers will possibly render it very costly for ESAF producers to produce SAF. And now keep in mind that this cost development prognosis or forecast provided by this study, which I've shown on the previous slide, which says, well, by 2050, we will have costs like $1,000 to $1,500 per ton. I have very strong doubts that this is realistic in this scenario where a significant share of the CO2 has to be captured from direct or via direct air capture. Now, let me conclude. Many aspects which are interlinked, so please keep in mind in general the whole subject of regulation and feedstock potential or feedstock categories is not only bilaterally dependent, it's rather a very complex network of aspects which are interlinked. So the question how the SAF market development interacts with the regulation and the feedstock potential as of today is very, very difficult, if not at all, to be forecasted. Take alone or consider alone how broad the range of forecasts from experts in the community is already as of today. There is no clear winner if we look at the technologies, just by the cost of the CAPEX and the OPEX of the technologies as of today. So all those technologies have to be kept in mind and have to be, let's say, monitored with respect to technology improvement, efficiency improvements, and so on and so forth. There is some hope that the feedstock potential could meet well the demand for SAF, at least on the example of Europe. And although it may appear that this was now a very European focused presentation, but I think a lot of what has been said can generally be transferred in one or another way to other regions in the world. Please keep in mind that when you talk about feedstock for SAF, that it might be valuable or meaningful to consider carbon as a separate topic compared to the energy which is used to produce SAF. So always ask yourself, my strategy, my technology, my value chain, and all that, is that robust with scenarios such as described the last two slides, like that several players may prefer to have other purposes for their CO2 than providing it for SAF production. Well, and then finally, please take this just as a kind of mix of aspects. It should illustrate there's not just one topic, not just one trend to be kept in mind. There are many trends which are interlinked, and therefore all of them have to be understood, their dependencies and their interconnections. So I'm sorry to say, probably the world is not going to get simpler. Rather, it will stay complex. but there's no alternative than dealing with that complexity. We have no choice. We must reduce greenhouse gases. And I think the best we can do is to share views and insights and expectations. And in this context, I'm thankful for having the opportunity, or having had the opportunity, to share some of my thoughts here today. And thanks again, Ralph, Santi, and Rebecca for giving the floor. And I'm looking forward to the questions. Thank you.
Georg, thank you very much. Really, applause from my side. And let me give you the first feedback directly, because I know you couldn't see that while you were speaking. All spectators are with us still. No one left the stadium before the end of the game. So really nobody. And that is already an indication to me that we couldn't have been, that we weren't off subject here. So thanks a lot. And I wasn't the only one asking questions. We have some in the pipeline, and maybe Santi, you can take over and guide us through, share the questions. And again, to the audience, you have the chance by pushing on the thumb up button to upvote questions that you find most relevant for you. So they will appear, as you see here, in the first with the two votes on top. So that steers us a little bit. We have only, I'd say, 25 minutes left. Maybe we can expand by another 5 to 10 minutes to make sure we are covering all the questions.
So thank you very much. Indeed, thanks a lot, Georg. We promised it was going to be a bit complex. I think we kept our promise and we fulfilled the initial intent. Before going into the questions, I think you mentioned a few kind of key points, maybe on my side also to reiterate those key points that are, in my view, the main takeaways. I mean, all these, let's say, uncertainties around the feedstock, around the production, all that is existing, and I think they will never be gone. There will always be some uncertainties looking at the future. I think you pointed to regulations as the main, let's say, tool to reduce these uncertainties. Also, if I translate that into risks, I understand that, I mean, if I'm an investor and if I read your presentation, I will be scared. But this is where the regulations will play a role. It will give certainty in one way or another, and there we have seen different approaches with the pros and cons. But again, giving certainty, or at least reducing the uncertainty, and also reducing the risk. I think in our previous discussion, you were also mentioning the role of these partnerships between different partners, between different actors, also as a factor, which could be, I mean, could be part of a regulation, but this is more, let's say, the facilitated, not necessarily by the regulation, but by the sharing of risk and the will to move forward in a kind of a united manner. So that will be another factor to share or to reduce the uncertainty and to bring everybody on the same, let's say, level of risk exposure.
Right.
Okay, I think that's from my side. I will, as usual, we will take the questions as the most voted ones. So you can go into Slido. There on the left-hand side, you have the QR code. It's quite straightforward. Let me just adapt the screen for me. So it's the first question I'm highlighting is the restriction of feedstock maybe the typing probably has been done in a device, in a small device. I understand the question is if the restriction of feedstock, isn't it constraining the feedstock market and making it more challenging to achieve the objective, probably related to competition, reducing the number of feedstock available. Yeah. Is it better to allow more feedstocks to give more market options?
Yeah. So frankly speaking, yes, this is a realistic scenario. I don't want to say, yes, it will be this way, but it is at least a realistic scenario that we run into that situation. And as of today, my impression is nobody or very few, especially including policymakers, are willing to already, let's say, react on such constraints. Rather, I would expect we have now a relatively clear, at least in Europe, a very clear framework to start. And I think there will be continuous revisions in the coming years, like every 5 years or at adequate points in time. And possibly then the question of which sort of feedstock might be included to release the pressure to reduce the pressure on feedstock markets, that there might be new steps taken. But as of today, I would say, yes, it is a scenario, a possible scenario, but we have to live with it. And the only thing we can do is really to start to go forward, provide new information, to provide experience, how the market evolves, how the demand really evolves, how the prices will be. Is it sustainable also economically for all the investors and stakeholders in the value chains? So I think all we can do is now go forward, even if we don't clearly see how will the world in 2030 or even more in 2040 or 50 look like. But the best thing we can do as of today is to start moving forward.
Thank you very much, Georg. Please, Christoph, as it also relates to the previous webinar, feel free to chip in or to complement the Georg reply or to take the lead in a specific reply. So we have the one which is obviously always expected. Yeah. We are discussing with colleagues from Southeast Asia for very good reasons. Yeah. So will palm oil be an approved alternative feedstocks? So I understand first, yes, it is already in some way, but please, Georg.
Yeah, I can confirm. The question always has to be, let's say, extended under which regulatory framework or under which regulatory scheme. So under CORSIA, very clearly, yes. Under RefuelEU Aviation, for example, clearly no. But again, let me refer to my previous answer. All this is as of today. And I wouldn't dare myself to make a statement how everything around that will be treated in 2030 or so. As of today, however, I would be very careful or cautious in spending high investments only on palm oil based, so HEFA type fuels. This is, you can do that, but you should be aware of the ultimate risks. That's my personal view. So please don't take this as an EASA statement or so. It's really my personal view here.
I think it's obviously the context, and I think you were showing a slide, if I remember well, it's at the beginning where you were showing the different CO2 or greenhouse emission reduction in percentage and how the different feedstocks were performing, I suppose also related to the processing and the type of processing. But there is also a reason in terms of, let's say, environmental performance of the different feedstocks behind. And it's not only in this case to palm oil.
Yeah.
Moving and maybe connected following this, the next question says there are some SAF pathways and feedstocks as main products, such as the sugarcane, but they have a GHG saving higher than 65%, as demanded by EU regulations. Yet they still will not be recognized by the RefuelEU Aviation. Is that correct? And here we have someone with a deep knowledge on the subject.
Yeah, so I can confirm. Please keep in mind that the RefuelEU Aviation provides independent requirements. Independent means you have to meet all of them separately. And one of the requirements is the minimum greenhouse gas saving. That is met by sugarcane-based fuels in some ways, not all SAF paths, but especially via the alcohol to jet paths. However, it doesn't comply with another provision which clearly states no SAF from feed or food crops. So yes, you can argue about this, and if you consider the general or the original interest of the European Commission to exclude food or feed crops, one of the key drivers was to avoid too high greenhouse gas emissions, such as from indirect land use change. Now, if SAF from sugarcane, even including the indirect land use change, and this is done according to the LCA by the or in the framework of CORSIA. So the value, the high or the value for the sugarcane-based SAF includes indirect land use change, still reaches or exceeds the 65%, but still it is not eligible. And the reason was, how I understood the whole discussion, we don't want to have that sort of discussion. In tendency, feed and food crop-based SAF has a lower value and is not ultimately sustainable. Therefore, we as policy makers don't want to encourage such sort of feedstock for fuel production. So again, I'm just explaining, this is not my personal point of view. That's how it is provided by and decided by politicians to exclude that sort of feedstock in Europe. So maybe one last sentence. It is in fact insofar not fair as of today, because for road transport fuels, the Renewable Energy Directive still allows such sort of feedstock until 2030. But this is a limited time window. Yes, if you hear, well, some sugarcane-based fuels are recognized in the EU, yes, this is the case, but only for road transport applications, not under RefuelEU aviation.
Thank you very much, Georg. Maybe it's also a way of, let's say, diversifying the availability of feedstocks and avoiding at certain point competition on a specific feedstock. I don't know. That was just my own guessing.
No, this is a very fair point. I mean, the more you accept food and feed crops for fuel production, the higher the challenge for residue and waste-based fuels to compete with those sort of fuels. So this is definitely an important point that you raise.
Okay, the next two questions, I remind everybody, so we are overshooting a bit the initial time slot. I will propose going up until 15 minutes past the hour, at least at European time, so we can address those questions. The next two, I think we can put them together. They referred, I think, when you were showing the, let's say, the expected amount and the feedstock potential in order to provide the supply for aviation fuel. And you were referring to at least to the maritime sector as a potential competitor or something that will be also demanding. So the question, or the two questions are, what are the expected demands for maritime transport, for fuel maritime transport? And aren't you concerned by the competition with the maritime sector?
So first of all, yes, maritime is a competing sector for the same feedstock or the same, let's say, type of fuels, hydrocarbons or hydrocarbon drop-in fuels. And this is also addressed, for example, by this diagram here. Could you please confirm, do you see the slide or no?
No.
Okay. So the slide 8 showed this diagram, and it included the feedstock potential and explicitly stated, well, this is for aviation and maritime. And yeah, as you may remember, it was like 50 million tons, and now referring or comparing that to the 30 million tons demanded for SAF. So there would be some potential for maritime. There is one thing to be considered when you go into various studies, and you will find similar studies on maritime fuel demand. There is a fundamental differentiation insofar that many, let's say, market participants expect that a high share of fuels for the maritime sector in the future will be methanol, ammonia, maybe hydrogen or LNG. There are some others, but what I want to say is the options to move into other fuel or to benefit from other sustainable fuel pools is much broader, the range of options and the volume potential. So yes, in principle, there is competition for maritime. However, I see much more elasticity with regards to moving into other fuels categories.
And indeed, I think you are pointing as well to the need of having a coordinated policy approach across all the sectors, the feedstock market. So having a very holistic approach in the definition of those policies. And I think you also were mentioning, and Ralph already pointed out, the need of monitoring. I mean, you know, the regulation or the policy that you are developing won't be perfect from the start. It will be subject to a lot of changes internally, but also in the context. And this monitoring, making sure that, I don't know, for example, technological developments are in the pace that were expected, or if there are delays, how to come up with solutions for the policy not being, let's say, in a loophole at a certain point, and so on. I think those are very good examples.
Maybe just to
please,
add
Christoph.
some figures regarding this question, because what we always said is that those different sectors tapping into the same feedstock potentials, and if you only take, for example, the forecasted renewable energy that is needed in order to achieve the net zero goal for the maritime sector, we speak for the year 2050. I think that was also one of the questions. It means that the whole renewable energy capacity that exists on a global scale today is needed for that goal. We're speaking about 3,000 terawatt at the moment. So because also here, what Georg just said is the same technology pathways are also used in order to use that, for example, e-ammonia or e-methanol via hydrogen or via green hydrogen production. So, so definitely there are interlinks between the sectors, but as Georg said, there are other alternatives also for the maritime sector that may play a greater role and take a little bit of relief of this competitive factor.
Thank you very much, Christoph. The next question is more specific. Is certified palm oil accepted for SAF produce? And then the RSPO, CSPO here. Georg, I rely on your expertise.
Yeah, again, that relates to the question that was already raised earlier and answered earlier. It depends on the framework. And yes, there are frameworks where it is certified and recognized by market participants, but not everywhere in the world. So it has to be answered or to be investigated dependent on the region and the world, and dependent on the framework under which you want, or the framework which you want to comply with.
Very good. Thank you very much. Then again, looking at the time, maybe we can address 2-3 questions more. The rest will be replying written, and we will publish this together with the recording and the slides that have been presented today. So the next one I have in line is, do you have a forecast on what cities, airports in Europe will provide SAF incentives to airline operators? Would such incentive be feedstock specific or indifferent? So more related to volumes from whatever the source.
Yeah, frankly speaking, I have no such detailed forecast. I have heard of examples. However, my impression is the EU is currently interested in harmonizing all, let's say, activities from the various stakeholders as far as possible, including, for example, let's say, country-specific funding or mandate systems, that they will not be kept in parallel to the overarching EU system. And as far as I understand, that would also include how airport operators or cities act. So personally, I can't really make a clear forecast here, but I would expect that the EU has an interest to have a, let's say, a most level playing field among or across the whole EU, and that so far such schemes are at least not incentivized, but rather there is an interest to keep it, let's say, the same requirements and sustainability levels and ambitions everywhere. The only thing perhaps I should mention at this point, I haven't read or I haven't get access to the details, but what I found interesting is that in the press release on the very recent alignment or agreement between the Parliament and the Council, it was said that the Commission shall provide a proposal by 2024 on how book and claim can be applied in Europe. This is for me the first time in the context of the EU that I see that there's a clear let's say recognition that providing an option for book and claim would facilitate introduction and market uptake of SAF. And I think the question raised here regarding cities and airports has to be also discussed in view of what would that mean if you do not only need the physical, or you do not need necessarily the physical amount of SAF, but also purchase it via book and claim.
Okay, thank you very much, Georg. Indeed, that could be an interesting topic for the next webinar. So I think we are overshooting already 15 minutes the hour. We will provide the reply to questions to the following questions by in written, so we will post them in our website together with the recording and the presentation that has been presented. So thanks a lot, Georg. I think it has been very, very interesting. Obviously, we could spend the next hour continuing with questions and opening different ramifications on this. But I think we have to give it a close. Therefore, Ralph, please.
Yes, thanks, Georg, Santi. I'm really thankful about all these questions, these many questions. That clearly shows that the audience really started to warm up with this format, and that really makes these events that really makes it alive. So I'm sorry that we couldn't answer all the questions. As Santi said, we're going to publish them on our website. By the way, we have just published webinar 11 and 12 recordings along with the presentations. We do this also soon with this webinar, and I'm going to send a message to everybody once this has happened, and also with the pending questions that have not been answered yet. So we haven't lost too many, actually, even though we were overshooting, maybe 15-20%, but we are at the end we are reaching business closure in Southeast Asia, so understandably many also probably heading towards home. However, if you still have the time after this meeting, after this webinar, we're going to show you the 3 feedback questions, where you could also address subjects that might be of interest for you, that we could look into and consider for the next webinars ahead. We are thinking at the moment about sustainability certification still, and also a question from the past, adaptation of refineries to SAF, or any others subject to the feedback that we receive from you. Saying that, again, thank you very much for being with us. Stay tuned and have a good rest of the day. Goodbye, everybody.
Bye.